Hello friends, today we are going to study about buffers. So buffers are the mixture of weak acid and its conjugate base. For example, acetic acid and acetate ion can form a buffer solution. They can resist change in pH. pKa is proportional to 1 upon strength of acid. What is pKa? pKa is that pH at which weak acid dissociates 50%. This we already studied in the last video of our pH and pKa. I have provided the link at the end of this video for those who have not seen the video. Now, Henderson-Hasselbalch equation for weak acid. According to the equation, Ha gives H plus A minus. The dissociation constant can be given by the formula Ka equals to H plus multiplied by A minus divided by Ha. Applying log to both the sides, log Ka equals to log H plus log A minus upon Ha. Applying negative sign, minus log Ka equals to minus log H plus minus log A minus upon Ha. What is minus log Ka? That is pKa. This also we studied in the last video. What is minus log H plus? It is pH. Minus log A minus upon Ha. So that means the formula became pH is equals to pKa plus log A minus upon Ha. That means the pH of any buffer depend upon its pKa as well as the concentration of conjugate base and acid. So pH of any buffer depends on pKa of the weak acid and also on how much amount of acid and conjugate base is present. So the formula pH equals to pKa plus log concentration of A minus upon concentration of Ha. That is concentration of conjugate base divided by concentration of acid. So in which condition pH will be equal to pKa? When this value will become 0. And how we can make this value 0? Log 1 is 0. So we have to make here 1. To make 1 here, the concentration should be equal. For example, 2 by 2, 1, 5 by 5, 1. So the concentration should be equal. So if the concentration of conjugate base and acid are equal, in that case, pH will be equal to pKa. So if we know the pKa value, we can calculate the pH if we also know the concentration of conjugate base and its acid. Now, in which condition pH will be more than pKa? So pH is directly proportional to A minus concentration. That means when the conjugate base concentration is more compared to acid, in that situation, the pH will be more than pKa. If the concentration of acid is more than conjugate base, then pH will be less than pKa because pH and Ha are inversely proportional. Clear? So if concentration of conjugate base is more compared to acid, in that situation, pH will be more than pKa. If the concentration of acid is more than conjugate base, in that situation, pH will be less than pKa. Now, suppose you have given pKa 3.76 and you are asked to make a buffer with pH 3.76. How will you make it? So the formula is pH equals to pKa. That means here 3.76. You want this value only to be the pH of the buffer. So for that, here you should make it 0. And how you will make it 0? Told you just now. You have to get this value of A minus upon Ha as 1 because log 1 is 0. And in which condition this will happen? If you add equal concentration of conjugate base and acid. Now suppose you are given pKa value 3.76, but you have to make the pH of the buffer 4.76. How you will do? So 3.76, if you add plus 1 here, then it will become 4.76. And how you will get plus 1 here? So the value of log 10 is 1. That means you have to add more concentration of conjugate base compared to the acid. So the base concentration should be 10 times more than the acid. So log 10 by 1 will be log 10. So that means the concentration of your conjugate base should be 10 times more than the concentration of conjugate acid. Then only it will become log 10, and log 10 value is 1. So this one will add up and it will give the buffer pH 4.76. You have pKa 3.76. You want pH of the buffer 2.76. So that means 3.76 minus 1 will give you 2.76. You have to minus 1. Then only you will get 2.76. Now, how you will get minus 1? So log 10 to the power minus 1 is minus 1. Log 10 to the power minus 1 means log 1 upon 10. So that means the concentration of acid should be now 10 times more than the concentration of conjugate base. Then only you will get pH less than pKa. Understood? So practically the buffering unit is plus minus 1 of pKa value. That means if any pKa value is given to you and if you are asked that what will be the buffering zone for this buffer, so it will be plus minus 1 of this pKa value. That means if pKa value is 3.76, it can provide buffer from 2.76 to 4.76. When the concentration of base and acids are equal, that is the best buffer because it can resist change in pH without addition of extra acid or base. So more pKa means more buffering range. For example, this compound, it's having 3 pKa, pKa1, pKa2, pKa3. It means it has 3 different buffering zones. According to pKa1, which is 2.8, it can buffer between 1.8 to 3.8. According to pKa2, which is 8.5, it can buffer between 7.5 to 9.5. According to pKa3, which is 9.5, it can buffer between 8.5 to 10.5. So the formula is pH equals to pKa plus log A minus upon HA. Remember? Now this we can also write in this form. pH equals to pKa plus log deprotonated form by protonated form. A minus. That means devoid of proton. So we can write it as deprotonated form. HA means proton is present. So we can write it as a protonated form. If pH is equals to pKa means A minus and HA concentration are same. That means percent wise if we talk, both are 50%. If pH equals to pKa plus 1, that means pH is more than pK. In that case, deprotonated form will be 90% and protonated form will be 10%. How? In the last slide, what I said you that if pH is more than pKa by 1 unit, like in the last example we saw 3.76 to 4.76, we have to add 1 here. Right. For 1, what we learned, it should be log 10. And how we will get log 10? If the concentration of conjugate base is 10 times more than the concentration of acid. So log 10 by 1 will be log 10. So this we are saying 10 times more. That means we are talking in ratio. So in ratio, how we calculate 10x plus 1x? That is equals to 11x. If this 11x we take it as 100%, so how much will be this 10x value? So if 11x is 100%, so 1x will be 100 by 11, 10x will be into 10. If you solve this, you will get the answer 90%. So in percent if we talk, it is 90%. So here the same it is written. If pH is 1 unit more than pKa, the deprotonated form is 90%, protonated form is 10%. If pH is 2 unit more than pKa, deprotonated form is 99%, protonated form is 1%. If pH is 3 unit more than pKa, deprotonated form is 99.9% and protonated form is 0.1%. If pH is 1 unit less than pKa, deprotonated form is 10%, protonated is 90%. Reverse of what if it is 1 unit more. pH is 2 unit less than pKa, deprotonated is 1%, protonated 99. If pH is 3 unit less, deprotonated is 0.1% and protonated is 99.9%. Now buffers are independent of limited dilution. That means if you dilute the buffer, the pH won't change up to a particular limit. But if you dilute it a lot, then it will affect the pH of the buffer. So buffer can resist change in pH with limited dilution. If we do excessive dilution, then acidic buffer will have pH slightly less than 7. Basic buffer will have pH slightly more than 7. Now the question, if pK is 4 and the concentration of acid and base is 0.1 molar each, volume is 1 liter, what will be the pH? Because the concentration are same, so pH will be equal to pK. This only we learned. So here pH will also 4. Now if we dilute the same solution to 10 liter, what will be the new pH? If we dilute it to 10 liter, now the concentration became 0.01 acid, 0.01 base. But the concentration are same. So the pH will again remain the same, that is 4. If we dilute it to 10 million times, then it will affect the pH. And how it will affect? Here. If it is acidic buffer, the pH will be slightly less than 7. If it is basic buffer, the pH will be slightly more than 7. So buffer can resist change in pH, but that does not mean it does not change at all. If we add acid or base, there occurs change in pH in the buffer, but that is very negligible. So if we add acid to the buffer, the pH change slightly less than 7. If we add base to the buffer, again the pH change, but it is very negligible, but it will be more than 7. Now again, the same formula, pH equals to pK plus log A minus upon HA. Now the strength of the buffer will depend upon the sum of the moles of an acid and a base formed in a liter. For example, suppose the concentration of HA given 0.01 molar, concentration of conjugate base given 0.01 molar and the pKa given 4.76. Another solution having concentration of HA 0.1 molar, having concentration of conjugate base 0.1 molar. But the pK is again the same, 4.76. Now which buffer is stronger? How you will get? You will add 0.01 plus 0.01. Sum of the moles of an acid and a base. Here you will add 0.1 plus 0.1. So it is 0.02. It is 0.2. Clear? Which buffer is stronger? Second one compared to the first one. Okay. So strength of buffer depends upon the sum of the moles of an acid and a base formed in a liter. Now it's a question time. If 10 millimolar acetate buffer whose pH is 4 diluted 1 million times with distilled water whose pH is 7, what will be the pH of the diluted buffer? Will it be 4? Will it be 8? Will it be 7.04? Will it be 6.96? Okay, we are diluting the buffer 1 million times. What will be the pH of the diluted buffer? Clear? So you have to answer. Do write me in the comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.